right, well, it looks like it is noon, so I will go ahead and get us started. Appreciate everybody's time today and for being on. Um, today's topic, I think, is of extreme value to people of all sorts of different fields. If if you wouldn't mind, I mean, I would love to do this in person. We're still in COVID-ness right now, so we're doing it by Zoom. But if you have a second, if you could put into the chat um, whether you're an engineer or an architect or whatever field you consider yourself to be, kind of an informal poll. I'll do a formal poll at the end, but I'd just love to get a sense of who's on the call today so I can try and target this talk a little bit better because it can be fairly broad. As we get started, there's a little bit of front matter as usual. Initially, as long as my mouse is working, who we are and what we do. So we are out of the University of Idaho, a little research branch governed by College of Art and Architecture. Happy to be there. We've got myself, Damon, Ken, and Dylan as full-time staff, although Ken is off to design and build his home in the mountains shortly, so we wish him well, but he'll stick around. I'm desperately trying to keep him on as long as possible because he's been a wonderful mentor, but he'll be stepping down to part-time next week, so congrats to him. We also recently lost Lindsay Watkins. She is now working at GGLO, so we wish her well. And we brought on board Isabel Boycourt. Very happy to have her here as an intern. We are posting, I believe, next week, if not sooner, a new position for a research scientist, research professor type who can help with some of the technical work here, as well as we're always looking for new interns, particularly new architecture interns. We pay tuition in school and a stipend while students are in school. So if you personally are interested or know somebody who might be, please reach out and let us know. Need to start by saying thank you to Idaho Power, who's sponsoring this talk, but they sponsor not only this talk, but several other programs as well, including technical design assistance. So this is where our lab reaches out as kind of an educational consultant. We're not trying to step on anyone's toes, be consultants on our own. Instead, our goal is to help your own firm to accomplish the goals, train you on how to do these tasks internally yourself. So that might be things like exploring a new technology, learning how to do energy audits of some of your buildings, or assessing particular parts of your HVAC system. Idaho Power provides free support of up to $2,000 worth of our time. So think of us as a helpline. I don't know how many of you use the U of I extension for gardening, the Master Gardening Program, but it's pretty neat. You can just call them up and say, hey, I've got bugs in my lettuce. What do I do? They can help you with that. In the same way, we can help you with your energy efficiency projects. So say, hey, I'm replacing some lights. Do I need to replace both the ballasts and the tubes, or can I get away with just LED replacements? Things like that. Consider us a resource for you, thanks to Idaho Power. If it's going to be up to $4,000 worth of our time, then there's a quick turnaround for some approval process where we just lay out what we hope to do. We seek Idaho Power's approval, and then we can move forward on it. Once again, this is commercially focused, so we can't do much on multifamily, but we can help on commercial portions of buildings. If you want us involved from the very beginning of a project all the way through the end, or doing some really in-depth analysis, that's where the Phase 3 program comes in. 75% of that cost is covered by Idaho Power, so it's a great deal, and 25% is then covered by the owner. Another program, skipping past it, is the Building Simulation Users Group. Now this lecture series, similar to our Lunch and Learn, is much more on the technical side of building energy modeling. So it's focused on topics like, well, in August, we've got 2D heat transfer using the program Grasshopper. September 22nd, we'll be talking about luminaire level lighting controls and a demonstration, hopefully showing how those can be incorporated into energy models. One of the strengths of IDL is our energy modeling program. Our students learn it while they're here, and we can help your firm kind of incorporate that into the design process, because we believe it has the potential to save a lot of energy and a lot of headaches, increasing communication between architects and engineers early on. So if you use energy modeling or are just curious about it, check out our BSUG webinar series. You'll get prizes if you're in Idaho Power service territory. We do a drawing for those. So not everyone gets one. We're not Oprah, but you can pick up some, energy savings toolkits and things like that. Speaking of tools and the like, one thing that is free to all Idaho Power customers is the use of our, energy resource library. This used to be called our tool loan library. We've expanded into books and other programs and things like that. So we've rebranded a bit, updated our website, made it a lot easier to check out and use these tools. We've updated some of the owner's manuals, which can be a bit dense and monotonous, into very simple user guides, so you can be up and running very quickly anytime you need to play Sherlock Holmes on a building that's not performing the way it should, or working on some commissioning projects. All of these are focused on, say, indoor air quality, making sure your HVAC is efficient, examining the thermal envelope, logging performance over time if you want to do some Energy Star certification, things like that. So check out our website, idlboise.com. If you know the problem you have, but you don't know the tool you need to fix it, let that be our problem, and we can pick it out. Just describe what you need and we'll help you. I'd like to also mention that Idaho Power has their own programs, a variety of different incentives for commercial and industrial customers. So that can be for retrofitting an existing building or designing an energy efficient new construction project. Major renovations might be an addition or expansion. Maybe you're changing the use of a space, repurposing a warehouse, or adding a load to a space, like adding an AC unit when the space was originally unconditioned. There are also incentives for reducing the load during the peak of summer, which we're going to hit here shortly if the weather forecasts hold true. Hopefully we aren't all sweating in 108 degrees next week, but we'll see. And there's some free energy saving kits for businesses. So I'll also turn it over. I saw Shelly Martin on here. There might be some other Idaho Power folks. Feel free to interrupt me if you want to speak about the new program rollout, which is now live.
Hi, Damon. This is Cherie. I'm on the call.
Thanks, Cherie.
And just wanted to remind everybody, we did roll out a new program for new construction and major renovations, and also our non-lighting for retrofits rolled out at the same time. Rolled out June 15th. The information's online. I've got a new application. I've got a new brochure. I've got new information on the incentives. In addition, this rollout, actually, we're adding some new measures. So take a look at those. Also, just to remind you, if you already have a pre-application in under the old program, you're grandfathered into that program, and that pre-application and final application are the same application. So you don't have to pull a new final application if you are already in the system with the pre-application. Also wanted to let you know that we did double our professional assistance incentive. That was for a limited time. It was supposed to end this September 23rd, but we have decided to keep it on longer. It still is a limited time and may end in the future, but we want some more time to evaluate its usefulness of doubling that. It used to be 10% of the incentive up to $5,000 per project. Now it's 20% of the incentive up to, used to be 10% up to $2,500. Now it's 20% up to $5,000 per project. So that will continue. If you have the old application, it still shows on the bottom that 10%, but when I process it for payment, I change that to that 20%. Doesn't take away from the owner's incentive. It is an addition to help the architects and engineers to kind of compensate some of their time to be involved, to provide me the paperwork and what's required to submit that final application and get that owner their incentive. If your firm is interested in me doing a quick casual, what are the changes between the 2018 program and the 2021 program, I'm available to do that. I'm starting doing that a couple this week. So let me know, feel free to reach out to me by email or just call me and I can set something up with your firm and go over casually kind of what are the differences between the program, what do I need to know, what new measures, what changed and whatnot. Thanks for the couple of minutes, Damon, I appreciate it.
Yeah, thank you, Sheree. Great to know that that program's being extended at new level. So thank you. All right, well, we can kind of get to the heart of the matter today, which is high performance sequences of operation for HVAC systems. A bit of a mouthful. It's essentially an introduction to this guide, which was published in 2018. For the purposes of flow and things like that, I'll ask participants to remain on mute while I give kind of a short presentation. And then I'll open it up at the end, hopefully 10 to 15 minutes, if not more, for kind of question and answer, chat back and forth. Thank you for everybody that put in their kind of field in the chat box. Looks like we're skewing more towards the engineering than the architecture today. So in terms of the IDL balance, we're tipping a little bit, which I'm comfortable with being an engineer. So that's also appropriate for the standard, which is very much engineering focused. It's a wonderful guideline that's really targeted at those who wish to incorporate these practices into design or even into retrofits. But it doesn't have to be just for one individual. You know, I want to start with like, who is this for? And it's kind of for everybody. I think in order of application, it's most relevant for those that are, you know, designing these systems. But it's extraordinarily helpful for control contractors, commissioning agents, operators, and maintenance technicians who are dealing with these systems every day, these HVAC systems, as well as building owners that want to really kind of standardize these practices. So, you know, what's the goal of having this guideline or the standard for control sequences of HVAC? It's a standard and guideline for control sequences. That may sound obvious. I don't mean to be just restating it, but the idea is that we don't have to reinvent the wheel every time we come to a new building. We want to make things as consistent as possible for contractors, as well as, you know, commissioning agents. So improving that workflow so there's less time on site, less headaches of what is the setting supposed to go to? What was our default here? How are we labeling these points? We want to make sure our HVAC systems are easy to diagnose, easy to keep tuned up, and so that, you know, owners can, you know, point to this guideline and say, hey, you know, I want my HVAC system to be in accordance with this. Now, this isn't relevant for every HVAC system at this point. It's really focused just on VAV systems right now. But like with many ASHRAE guidelines, it is under continuous development and improvement. So they anticipate adding more and more systems as they move forward and as the team kind of works on it. So what's in it exactly, other than performance sequences or sequences of operations? It's very practical. It's really meant to be applied. So this gets into, you know, very dense details of what actual set points and VAV settings should be, the control points you want to see from each piece of equipment, including things like naming conventions and then some of the control sequences. And you know, everything from, you know, the design process, and this applies to architects as well. So when you are starting to zone a building, looking at, okay, how should we, when we're controlling this, group these different rooms together? Which spaces are going to be sharing thermostats, sharing VAV boxes? Are these going to be in parallel fan powered boxes like on a perimeter, or are they going to be in series like in an interior zone? And if so, how do we name them? How do we group them? It's really meant to be kind of open at your desk while you're working. It's not something you can just sit and read through and absorb all at once. I have tried. I will fully admit that a couple of weeks ago, I was trying to read this and drifted off for a minute into sleep because it's just very dense. It's one of those times when you like jostle yourself awake and realize your glasses are askew and the last 5 minutes have disappeared. Hopefully that doesn't happen to you, but it's very difficult to just, you know, pick this up off the shelf and read through it. Some of the other design guidelines are meant for that, particularly like their dedicated outdoor air system reference manual. Some of their ground source heat pump things are much more not novel-like, but easier to kind of peruse through. Whereas this, it's meant to be, you know, integrated into the process while you are working on it. And that is the easiest way for you to really absorb this information and you know, work on it. Similar to like homework in a textbook. Like you want the textbook open, but you're not usually reading through the chapters. It's much more like looking at example problems, applying it to your own homework question, and working out the details from there. So it's really getting into kind of the nitty gritty of it. So why do we use this? Why do we have this open either on our desk, or if you do buy it, once again, this is part of our energy resource library. So you can check it out if you do feel like you're really struggling with insomnia and need something to page through, or you have a project and much more practically, it's a VAV system and you're worrying about certain control sequences or something like that and want to quickly reference this. You know, fill out a tool loan request and we'll send it over to you. It can also be downloaded as soon as you buy it. If you buy it on your own, which I would recommend, it comes with a downloadable Microsoft Word document. So it's very quick to type into the search bar and find exactly what you want, you know, down to like the histories of alarm systems and things like that. Very, very quick to search through, which is great. But why do we have it in the first place? Why do we have a guideline? Do we need one more piece of red tape? It is a guideline. It's not a standard. So it's an option. It's not required of all systems, but it can lead to really dramatic energy savings. That's why Idaho Power is sponsoring this, is because by having a properly controlled HVAC system, you're not wasting energy, and nobody wants to do that. Nobody wants to be the person that's yelled at for leaving the door open on a 100-degree day, right? That's a simple thing, but that happens all the time in commercial buildings, except it's just less obvious. It's less hidden that that damper is at the wrong position or has been scheduled the wrong way, which is the exact same thing as having a window open and all that cold air blowing out, right? But not only just for energy savings, it can really help designers save time on their own sequences and their own kind of workflow. Like I said, you don't have to reinvent the wheel every time. They straight up say, you know, please steal from the standard. Use this guideline as your standard practice. Every project's going to be different, but if we can develop the same kind of conventions and things like that, then you know, kind of moving forward, you can particularize it to our climate here, Boise Climate Zone 5B, but really just internalize this workflow, this way of doing things for programming your VAV systems as you're working on different projects. So that after a while, it becomes second nature. I'm sure each firm has their own defaults and particular conventions and things like that, which is great when you are the only one involved in that project. But what happens when you design a building and then later on a different firm comes in for an addition or a renovation, and they have to go through and figure out your particular firm's naming convention, your particular firm's way of managing, duct static pressure and things like that. And that just leads to headaches. That leads to things just not working as they're supposed to, and a lot of dollars for commissioning agents who are wonderful. I don't mean to be knocking commissioning agents. Their whole purpose is to make sure buildings work the way they're supposed to. But if we're all on the same page from the beginning, if we have this consistency, it will make it much easier for these buildings to be at high performance, to be efficient, as well as being on the other side of the design, being the person that's on the ground working. So, building operators, they change jobs. They move from building to building. Even say, firms like Oppenheimer or TOK or others, their operators may change different facilities, and if they have to relearn everything, which they do, each building is a special snowflake, just like us millennials. The more consistent it is, the easier it is for them to come up to speed and to make sure that the building is working properly. I know I'm harping on this a lot, but that's really the power of this standard, and I think the value of it as well. So speaking specifically to HVAC designers, should we just take this as rote? Is this the end all be all VAV set points? No, it's under continuous development, but rather than being each in our own little bubbles where the owner is looking for something in particular, where the controls engineer is doing their own coding, and then the commissioner is out there kind of doing their own thing, and each of them has their own frustrations with the other field. I think I walked into a fly shop recently and was talking. He asked, what did I do? And I got an earful about professors and the elites and designers and engineers and architects who aren't actually doing things with their hands. We had a really jovial back and forth. It was great. But it's true. We do stay in our own fields, and here at IDL, this is a little bit of an ivory tower. I wish we weren't. We try to be as hands-on as possible, but I am not the one that is usually commissioning buildings or doing the actual coding of an HVAC sequence. I've dabbled a bit in the past, and every time I have, I've just gained incredible respect for people that do that all the time, who are masters in that field. So that was the idea behind this commission, this ASHRAE research project, of bringing everybody into a room, hashing out their differences, and trying to find something that works well, good enough for everyone. There are probably compromises for each field in terms of their ideal versus the actual. But this guideline tried to kind of gathers everyone's kind of diverse experiences, those who have been on the ground, those who are just sitting behind a computer designing them, and really kind of work on our tagline, that integrated process to collect input and develop this guideline. So what does that look like in practicality? Here's one sample of one of the tables out of there. And I think it's great because it gets into the details. This is looking at demand controlled ventilation set points and the carbon dioxide set point for specific rooms and specific categories of spaces. There is the standard kind of default, if you look at ASHRAE 62.1, of, hey, let's try and keep it, less than 600 parts per million above ambient. Ambient is, it varies by the place, but it's around 400. And then making it specific, let's add, 600 parts per million as our buffer zone, if you will. Above that, we start reacting, people get drowsy, they start yawning, we go through physiological changes. it affects our judgment. Instead of just using that 1,000 as a hard and fast rule, this standard really gets into, okay, what do you need for each space? Is 1,000 parts per million overkill? Well, maybe not at a daycare, but in a classroom, which is going to have a lot of people that really need to focus. I've been a high school teacher before. Any potential help I can get on making students focus and not fall asleep is fantastic. So they actually set a more stringent set point for their demand control ventilation of, okay, if the CO2 rises above, ideally 464 parts per million above ambient, whatever that might be, assuming that's 400, that means 864, then that's when we should increase the outdoor air, change the damper, and bring in more fresh air. So it's not as exciting necessarily as this brand new technology. LLCs are super slick. Looking at some of the new high efficiency heat exchangers, really exciting technology. This is more just in the trenches, but that's where these details really matter. For the architects out there that Mies van der Rohe, I can't remember if he said detail is design or God is in the details. Some platitude out there that we all refer to, dealing with details. This standard is wonderful for that. And once again, this is a standard to be used and adopted in practice at your firm. So you can have this handy and oh, hey, what did we design last time we built this school? Did we set all our CO2 monitors to kick on at the same time, or can we scale that a little bit and gain through efficiencies without racking our brains and making decision after decision after decision for each space, right? That takes time, that takes a lot of mental energy. You're exhausted at the end of the day, and the easier thing to do is to just, say, oh, we're just going to size it all the same. Here is an easy way of peer-reviewed research that gives you some defaults so you don't have to rely on your own judgment every time. Your own judgment is extraordinarily important, but having a starting point is very helpful. And this is a wonderful starting point from which you can kind of tweak according to your decisions and your needs. All right, so that's a little bit on HVAC designers, and if my mouse will cooperate, we can go to the next slide. Into control contractors. So, this standard will give very explicit conventions for how you should group zones. That they shouldn't be split by floors. That should be fairly obvious. That the floor area for each of these different groups should be less than 25,000 square feet. That might be more on the HVAC designer side. And if you didn't do that, then you're probably going to get some pushback or some grumbling. This is where some of those relationships start breaking down. You get contempt between fields because the controls contractor is like, hey, I can't actually manage all of these things if they're spread out so disparately. So, how do we group some of these controls? A lot of details in the standard on that. So let's look at an example of, names and conventions that are helpful. So this is like one project, and I love the standard because, or guideline, I should say, because it gives practical examples from which you can draw, and it's not just theory only. It shows how it would actually play out in the process. So here we've got like a little office space. There is a zone group name, and so that gets its own tag. And then how do you name the terminal unit tags? And then how should you group them based on, if they're occupied 24/7 or just during the working day, and you know, which are on which floor, things like that. By adhering to this standard, it's not up to every individual engineer out there. They can just have this formula, which they give you, and plug it in. So, you know, you have your specific air handler tag, you have your specific terminal unit tag, you have your conventions for which spaces are grouped together. And then that makes it very easy, or easier, to pass on to controllers, which makes it easier then for commissioners to make sure everything's working right, and especially for building operators when they get an alarm and need to figure out where is this happening, which terminal unit is causing, you know, some feedback error. They can know very quickly in the building exactly where that is, rather than just relying on George, who has been there for 30 years and knows which one goes with which, but nobody else is in George's brain, right? And if George is gone and there aren't labels on things, then it is a disaster trying to figure out exactly what's happening in the building. Been there, done that, would love to not do that again. So that's what the standard's for. So let's look at another example. And this kind of goes further into kind of the control points. So what are specific points that should be hardwired for one type of VAV system? So this is looking at a multi-zone VAV air handler unit, I believe with reheat. And it shows kind of whether this, this control is required or not, the type of backnet signal, whether that's an analog input, in this case, it's a digital output, analog output, digital input, etc., which will make it easier to integrate with other systems. That's what backnet is for. Once again, that's another standard protocol so that you can blend different systems if you need to. Siemens and Johnson controls might be at war with each other at Wall Street. We don't need to have them at war with each other in the same building if we do an addition. Let's make sure that they can at least communicate, even if they're not thrilled that, you know, one was there first and a new one's going in to replace it, right? And then know, okay, of the hardwired points, which ones are required, which ones are applicable, which ones are optional, but perhaps nice to have. All of that's kind of within the standard, which is wonderful. On the kind of commissioner and operator side of things, for people that are making this thing work, it's taking the perfect computer model into the real world. And the appendix of this guideline, you know, I'm not going to go through all of them. If you're seeing the camera, there's a whole bunch, which is extraordinarily helpful to be very specific about, you know, maybe this is a dual duct system, maybe you've got a plenum return, maybe these are fan powered boxes. There are layouts and suggestions for each one of these. And, you know, all the way down into, you know, how often these signals should be sent. You know, like dampers only adjusting once per minute, as opposed to, you know, more rapidly than that, which can cause wear and tear on the blades, or if they're articulating too fast, then they might break. We want to avoid those things. You know, it's an easy like slap of the forehead later of the commissioning agent saying, why didn't they do this in the beginning? This is your guideline to make sure that they are happier people in the future, which is what we want, right? And then, you know, so not only like control layouts, but also the logic. So this is a VAV reheat zone of, you know, when different signals should be sent, what your discharge air temperature should be. So we've got, you know, temperature here, and then our different lines of, you know, when we should be using proportional control or not, and shutting these different systems on or off, depending on if you are in that kind of happy Goldilocks area, or if you need heating from your terminal unit or cooling within that zone. And you can, you know, scale these particular to your environment, your needs. But once again, this is a very helpful guideline. Okay, where should those lines be crossing? Making sure there is a dead band between your heating minimum and your cooling minimum, so you're not just switching from one to the other and wasting energy in the process. Um, you know, details on things like minimum velocities on VAV, operational descriptions on pressure drops, damper positions, and even hard numbers on economizer operation, depending on the climate zone. What should that high limit be? For us in Boise, climate zone 5B, that high limit is at 75 degrees. In others, it's closer to 70 degrees. But we're pretty dry here, so we can kind of get away with a slightly higher limit, which is helpful to know if the original equipment is being shipped out of Georgia with maybe a different climate zone, different defaults. Make sure that you are checking for that. Static set points, examples, I won't kind of go into all the details there, but a lot of just helpful practical numbers for many different situations, as well as unexpected situations. So, things break, unfortunately. We live in a world with entropy, but how should we notify the building operator when something does break? Is this something that is critical to life? We've got a fire somewhere or a refrigerant leak, or is this something that is like, oh, it's getting a little bit warm in here, or we've noticed pressure dropping in this area for a little bit? How critical is that? They actually specify the levels of alarm and then how to tag these. Conventions, like I mentioned for equipment, the date and time, the level, description, so that once again, there's consistency. For example, one that I'm just kind of reading or read out of the book is, if a high temperature alarm is triggered at 100 degrees Fahrenheit and has an exit hysteresis of 5% for 1 minute, then the alarm will remain active until the alarm temperature drops below 95 degrees or 100 degrees minus that 5% continuously for 1 minute. So it gives specific numbers on the number of minutes, number of seconds each alarm should be active, when they can fade out, turn off, which can be very helpful. A lot of these alarms end up just getting muted all the time because operators are overwhelmed. And so that's why, EMS overlays like SkySpark are super popular right now, because they really go through and simplify and standardize some of these alarms. Things that should be simple and consistent to begin with. So, if everybody followed ASHRAE Guideline 36, I don't know if we would use SkySpark as much, or if SkySpark would get as many savings as they do. This isn't knocking them or any other analytics software. They're great and they can go far beyond a simple control sequence. But a lot of the promised savings that are reaped from these systems come from poor design or poor implementation of controls at the very beginning. The whole thing that this guideline is trying to improve. So once again, kind of getting back into why, energy savings. HVAC remains the largest energy consumption category, and a lot of it ends up getting wasted. It might not be as obvious as a window that's open all the time, but it could be a fan that's running at a higher static pressure than it needs to. So what does it look like to actually implement this? I've put a couple of citations in here. I'd recommend you check them out if you want increased reading on ASHRAE research that led to this standard. But HVAC inefficiencies can range from 30 to 50% or higher. And a number of simulation studies when they were first proposing this showed 9% to 33% savings on VAV systems just for proper demand controlled ventilation implementation in accordance with the standard. So just by going through that table that I showed with the CO2 levels and things like that, making sure that things are functioning properly. That alone accounted for up to close to 30% of HVAC savings. You know, maybe as little as 9%, but that's a lot. And you know, this is CBEX data. HVAC still remains the biggest piece of the pie. In August of this year, we will finally get the 2018 data. There's been a long lag, and I'm really excited to see what the balance looks like. I imagine lighting is going to go down even more. Plug loads might increase. I'm very curious to see what happens with HVAC. If HVAC remains still this large driver of energy consumption in buildings, this guideline just increases in importance. The other thing is not only saving energy, saving money, but saving people. Our tagline at IDL is like high performance, energy efficient design. High performance can be a bit buzzwordy. Another term for it would just be happiness. Not only like happy occupants, but also happy operators. So the spaces should be more comfortable. The equipment shouldn't be cycling as much, therefore extending its life. And eventually should lower kind of design and construction costs, because once again, you've got this roadmap for you. You're not having to, you know, come up with all these equations for breathing zone ventilation control each time you encounter a new project. That's in here. That's in this guideline, and you can kind of use it moving forward. You know, there were a ton of news articles. I picked one from the New Yorker, but it got picked up by the Atlantic, NPR. I'm showing my academic bias. Fox News picked it up as well. You know, everybody was talking about this. The idea that out of this ASHRAE research, people found, you know, the war of the thermostats was happening, and a lot of that comes out of poorly balanced VAV terminal boxes and who gets to govern the thermostat. The more you can increase occupant control, they actually found the more the savings were by really reducing overcooling during the summer. You'd think that leaving things to people would make things worse, and I'm sure sometimes it can, but in terms of management of thermostats and increasing occupant control over that, that led to not only, you know, happier people, but also you know, better energy performance, because people voluntarily turned their zone temperatures up slightly around 2 degrees Fahrenheit, which reduced overcooling discomfort by 50%. Overcooling is something we never wanted in the first place, right? So that's kind of some of the simulation studies and some of the research out there. I will say that there's some ongoing measurement. I'm taking this out of Gwelyn Pelagia's wonderful presentation that he gave this last December to SERDP and ESTCP, Department of Defense programs. You can look up that webinar series number 125. There is a joint project going on, or at least two separate projects in parallel. One is with California Energy Commission, and one is with NYSERDA. And they are, you know, actually measuring the cost to implement the standard for retrofits, as well as actual energy savings at a number of different sites. And what they found is real savings is up to 30% whole building energy savings. Recall that when we looked at kind of those pie charts, HVAC should only be 30% total of a building's energy use. So these HVAC systems were using way more than that. The main savings came from chilled water usage, hot water usage, fan energy, really reducing the electrical consumption and electrical costs, which you know, is particularly relevant as we're in a huge heat wave right now, or about to be, but a lot of the West is. And I'm sure Idaho Power would love to reduce their peak by having HVAC systems that operate better. But it's also of benefit to the owners. The paybacks for these projects, I could only identify 3 so far that had numbers on them. Hopefully the full results will be published later this August. But they're looking at between a 3 to a 10-year payback period. So if the owner plans on having that building over 10 years, definitely go for it. You know, ideally paybacks are even less. This could be entirely on the control sequencing side of things, so minimal replacement of equipment. Sometimes there is some hardware that's upgraded in the process, which increases the capital costs, and that leads to a longer payback period. But not only are you eventually making money back, you are keeping your people much happier in the meantime. And that's really of great value. The other positive that's coming out of this guideline, I'll just mention, is that manufacturers themselves are creating libraries in line with this guideline with those particular equipment tags, with those alarm sequencing tags and things like that. Train, Carrier, Automated Logic have already released partially some of those libraries. Some of the bigger players, Johnson Controls, Siemens, Allerton, currently have them under development. And I expect to see them kind of come into the marketplace with this kind of stamp of approval from ASHRAE shortly. So I'm encouraged about the future. We've gone from, you know, very different people in their own silos to arguing with each other about inconsistencies and building kind of this spider web that sort of works some of the time but is rather inefficient, to a much more consistent, streamlined process. That's kind of my intro on this guideline. Like I said, this is under continuous development and improvement by ASHRAE. So I'm excited to see it expand to other HVAC systems. I hope it kind of gives you a taste of what's in the standard and how it can really benefit your process. You know, similar to what I presented on last week about, you know, the energy modeling guideline 209, about incorporating those kind of standard practices into your workflow. This is, I think, well, as dense as it can be, while I admit to falling asleep to it at one time, I think it is of incredible value to us engineers, controls contractors, building owners, everybody, just by increasing communication and making sure we can work well with each other. I see that I'm about done with time, so I'll stop here. Feel free to email me if you have questions on this, and I'll also open up the chat so you can type questions in there. Looks like I've got one there. And then Kelsey, if you wouldn't mind launching the poll, I'd appreciate that. Thanks. This helps Idaho Power know how we're doing, how we can serve you better. Question from Brad. Thanks, Brad. You've got a lot more experience in hardware and some of these control sequences than I, so I appreciate the question. Does the guideline address how points should be named in a DDC system, and does it address any BACnet best practices? Yes and yes. Once again, it's narrowly focused on VAV. And in terms of the details of BACnet, it kind of references back to the BACnet protocol for kind of more details, similar to like some of the CO2 levels. It says, here are recommendations, refer to 62.1 for more details. This is not just ASHRAE trying to get you to buy guideline after guideline. It's just that there's, you know, many details and they don't want to get you kind of bogged down. Has anyone in the group used this yet or plan to? That's a great question for the group. I'd love to hear others chime in. Or we can have awkward Zoom silence. That works too. Yeah, I certainly hope that more and more people will at least adopt portions of the standard.
Hey, David.
Hey, yeah.
This is Rick at Musgrove. Yeah, I wasn't aware of the standard, but I'm going to run it up the flagpole here at our office. You know, controls and stuff, at least for me, was, you know, kind of learning like drinking from a fire hose, so to speak. And I don't know about other consulting firms, but, you know, we all have our own kind of schedules or control diagrams that we've developed, and we've tried to organize them and standardize them here within our office. But yeah, I think especially for younger guys coming in, I'm gonna run it up the flagpole and see if we can buy the standard.
Great. Thanks, Rick, and thanks for chiming in and being on today. As I think, like you said, it's overwhelming. It's just like drinking from the fire hose, and it can be overwhelming to overhaul your own workflow or your own conventions and systems. But I think even just piecemeal working on it, like one piece at a time, of like, oh, at least we're going to change our tags on AHUs or things like that. And slowly kind of shift more and more in line with the standard, I think will be of great value. And then you'll be kind of up and running, especially as more manufacturers and things like that, those trains, those carriers, then it becomes just, easier in terms of communication and your own workflow and consistency. Thanks. Any others? Questions or comments? I know one of the challenges of VRF systems, at least I've heard, is kind of once you adopt a particular manufacturer, you're really set with them because they have so many specific variables and control sequences. So this standard might be a little bit slower to shift into that field. But so many buildings are VAV, and when VAV is done well, it can be extraordinarily efficient. It can also be inefficient if it's done unwell, done poorly. But I think this really tries to get away to eliminate some of those concerns, those headaches that people complain about with VRF systems, about how opaque they are, about how difficult they are to edit or understand. It's the idea is, yeah, these are complex systems, but let's make them as easy to understand as possible. All right. Well, my email's on there, as is our website. Oh, okay. Another question from Brad. Thanks. Reviewing current in-house sequence compared to guideline 36 could be a good start for designers. Good point. Does IDL have 36 to loan? We certainly do. So we are happy to check this out, and you can get it at your office and then see if it's of value to you or not. I'll double check with Dylan right after this to make sure it's listed on our website under that energy resource library. But if it's not, just send us an email and we'll make sure that it is. That's free to all customers working in Idaho Power territory. All right. Well, looks like it's 12:54. I'll give you back 6 minutes of non-Zoom time. But thank you all, and appreciate your time today. Look forward to seeing you